About force and laws of motion, we are going to explore in this lecture. You will understand what is a motion, types of motion, and as well as laws of motion. What are those laws of motion that nature follows? Okay, uh, all those points will be covered in this slide. Uh, in each slides will be valuable for you. If you have any type of question can be question can be who should watch this lecture, then I would say this lecture is for those who are new and who want a basic understanding of force chapter and laws of motion. Then it is a too much basic. So if you want a basic understanding, then this is for you. And if you want to gain knowledge, then this is also for you. For the From the perspective of examination, yes, I would not say directly whatever you are studying, those questions will not come directly from this, because I don't know which standard you are. uh, but it will be useful if if you are at a high standard. But as I told you, this is a basic, so I would not say that it will not be useful for you. It will definitely be useful for you. Okay, you can watch this lecture as a knowledge, to gain knowledge, so in this slide, you have got answer what if you are new, then this is for you. If you want to gain a knowledge, then this is also for you. uh, and one question I want to ask you: ask to yourself, why are you watching this lecture? That's it. Is this important to watch this lecture from your side? Then if yes, answer is coming yes, then watch this lecture. And I told you who should watch this lecture, so I told you. Now think do you think you what why should you watch this lecture? So in this lecture we are going to cover what is a force, types of a force, as well as the laws of motion. This is a part one, it can be part one. And here it's my name, standard is ninth, it's me. I am moving towards the next slide. Towards the next slide. Here, as you can see, we have two figures. Here, as you can see, we have two figures. We are starting with the introduction of a scientist. These are those scientists which have discovered something that we are going to explore in this slide. Here, name of this scientist person is what? Galileo. I am not able to pronounce this correctly. If you can pronounce correctly, then you can pronounce. So born of this person was when 1564, and this was the time where he died. Now this person is also now this person I know who is this Sir Isaac Newton. Whatever we will be learning about laws of motion, about motion, types of motion. So this was discovered by this person. These two persons are those persons who did a lot of experiment uh, for something, and that's something I will show you in slide. So name of this scientist is what? Sir Isaac Newton. And born of this person was what? 1643, and he died at this time. This was an introduction of these two persons which are important to know who is this, who is the he. So these are scientists, and this scientist discovered something that we will be exploring in this lecture. I am moving forward. Here we have four figures. One is a cycle, second is someone is riding, third is there is a ball which is in a rest. Ball is not moving. In this figure, ball is not being shown as moving. Okay, here is a person. Here is a person who is who is hitting the ball, hitting the ball. From this figure, from this slide, what are you understanding? I would say here this object is in rest, but here this what is object? Object is a cycle. Here cycle is in rest, but here cycle is in motion and someone is riding. Here cycle is in motion, in a rest, but here cycle is in motion. Nobody is applying force on this object. That's why it is not moving. But in this case, someone is riding this cycle. That's why this cycle is moving. So what are you observing? You are observing that someone will come to apply force on object. Then that object will change its self position. Then we will be saying what moving object. We will say moving object. So remember, there are a lot of objects that are in a rest, and on the other side there are a lot of objects which are in motion. In this same this object is in rest, but in this what is happening? A object is being kicked, a object is being hit by a person. So this person is applying force on this object, So here in this figure, ball came into motion, but here ball is in rest. So how motion begins? So motion begins when force is applied. Okay, this is what was about in this. Now how motion stops? How motion stops? Okay, let me go back side. Here first of all object will be in a rest, then someone will apply, then force will be applied on the object, then that object will come into motion. First of all object will come into rest. Now when force will be applied, then that object will come into motion. Next is what? How motion stops? A object which is moving. Now how will a moving object stop? This is question in this slide. So answer would be what? Here ball will be coming, ball is coming. Now he will apply force by using two hands, isn't it? This is it will happen? Is it will it happen? Yes, it will happen. Here he will apply force and moving object will be coming towards this person. Now this person wants to stop the ball which is coming. What will he do? He will apply force by using two hands, and this is the process. Here again, a object which is in rest, to come that object into motion, we will apply force. Same here, a object which is moving, again we will apply to stop that object which will be moving. Again, to come bringing, if object is in a rest and we want to bring that object into motion, then we will apply force. If a object is moving, if you want to stop that object which is moving, then again we will apply force. So what are you understanding? What are you? Object will change something, it means force was applied. That is what you are understanding. Here a person is applying brake so that car can stop, but here is also advice which can be used to accelerate. About accelerate we will understand later. Right now you understand, here vehicle is moving, and someone is riding in this vehicle. He wants to stop the vehicle. Then what will he do? He will not use his hand to stop a vehicle. It will not make sense. Rather, instead he will use a device that is found in a vehicle. So what is that? That is what? Brake. By using brake, he is applying force so that moving vehicle can come into rest. Brake is applied when vehicle is moving, and when brake will be applied, then vehicle will come into rest. So here brake will be external force. Okay, next. In this, what are you observing? You will have to observe, because this is a subject which needs to observe. When someone will observe, then that person will be able to understand what is happening here, what is not happening, what is invisible, what is not invisible. All these things will be happening, but you will have to observe. Something will be happening, but you will not be able to observe. Then you will have to focus. Now here, force. We came to the main topic, which is important. Without this topic, nothing can move towards backwards. Nothing can be moved without applying force. So here we are understanding definition of a force in this lecture. Force. Here a hand you can see. Let's say this is your hand. Otherwise this is my hand. Now there is an object. There is an object which is on table. Which is on table. Which is on a table. Here what is happening? You are pushing this object. Then right now this object is in rest. It is not moving at all. When you start pushing this object, then what will happen? This object will change its position, isn't it? It will happen. It will happen. When you will apply force on this object, when you will push this object, then this object will change itself. At the same time, it will cover distance with respect to time. Means when a object will come, then that object will cover. When a object will move, when a object will cover distance, then that object will cover time. How much time was taken when a object moved from a scratch till the end? Here in this figure, you are observing that somebody is pushing the object. But in this figure, you can realize that you are pulling this object. Either you can push the object or you can pull the object. One or two more things. What you can lift this object like this. You can lift the object. This is also force. You can apply perpendicular force on object like this. Right now we need to understand what is a pull, what is a push. Push is just like that we apply a force. This is what push. Pull, which means we are pulling an object. So this is a definition of a force. A push or pull on a body is called force. That's it. In a one sentence, this is a definition of a force. Otherwise, you can understand when something is pushed, when something is pulled, is called force. Now next, balanced and unbalanced. Balanced and unbalanced. Let's complete this meaning of this balanced force. Balanced, from word you can say from this word balanced, which means right side, whatever is the value in the LHS will be equal to RHS. In left side, let's say value is 16, then in the right side value would be same, 16. This is at 16, this is at 16. Now you are saying that both are equal. Same with the balanced force will happen. In one side, number of newtons, amount of newtons is how much? 26. Then in other side would be same, 26. Then we are saying this type of force will be applied, will be considered as a balanced force. Now there is an object which is in between. In both sides there are two persons, and each in both sides persons are applying how much force. In one side, person are applying person is applying a force with 20 newton. Same in the other side, if two persons are applying force with 20 newton. So here amount of numbers in both sides are same. So here we can say forces are being applied with equal amounts. That's why it is said that in this case object will not move at all, because in both sides amount of newtons are same. That's why object will be in a rest. If object is moving which speed is a constant, then that object will be moving with the same speed. If forces are being applied with the same amounts in both sides, then that object will be moving with a constant speed. If it is already moving, then. But in this case, but if what if a object which is in a rest, then in both sides of object which is in a rest are being applied with the same units, with the same newtons, then that object will be as it. That object will not cover anything. That object will be as it. If two forces act on a body in opposite direction, and if both the forces are equal, then the resultant force acting on the body is zero. Such forces are called balanced force. Balanced forces cannot change the state of rest or motion of a body. It will be as it. So here, this side and this side both will be equal. Both are equal. Both will be equal. Then, okay, it is done. Now next we have unbalanced force. This side, both side number of newtons will be equal. In the discussion of unbalanced force, in one side, let's say number of newtons are 26, then in other side number of newtons, amount of newtons are 36. Then this type of forces will be called as unbalanced force. Here what is happening? In one side is something. If in one side there is an amount of newton which is 26, then in other side any number can be, but except 26. This is what is the meaning of unbalanced force. In this case, what will happen? Object will move. If object is in rest and unbalanced force are being applied on object, unbalanced force are being applied on object, then that object will move in one side. It will happen when forces are unbalanced. Then, okay. If two forces act on a body in opposite direction, and if one force is greater than other, then the resultant force is not equal to zero. Such forces are called unbalanced force. Unbalanced forces change the state of rest and the motion of the body. If moving object, a speed of moving object is a constant, then unbalanced force are being applied. Then that moving object, a speed of that moving object will decrease, will increase. Okay. Now next we have inertia. Inertia is just a lazy. Okay, inertia is just a lazy. A property of a matter which resist change to the state of motion. Inertia in our daily lives. In front of me there are two copies which are in rest. In front of me there is a keyboard, there is a mouse, there are a lot of things which are in rest. These objects will be in rest if I don't apply force on this object. Now I want to pick a book. Then be, then what will I do? Of course, I will go to that book. Then I will pick that book. So here I am applying force. But before I apply force, then that object was in rest, will be in rest. This is what is inertia. That object wants to be in a rest. Now, what if a object is moving with a constant aspect? That object will be moving with a constant aspect. If nobody is going to apply force on moving object, then that object will be moving. But when force will be applied on that on moving object, then that object can stop or can be accelerated. Here in this, let's visualize this. Here, what is happening? It is already in a rest. Here you came and you did like this. So this was in a rest. It came into motion when you applied force. When you applied force, these books are in a rest. Here this is in motion. Here this is also in motion. This will be in motion, but external force will be applied. Then this will come into rest. Now we have these examples of inertia of rest. A passenger in a bus jerks backward like this. When the bus starts suddenly, because the passenger tends to be in a inertia of rest. You are in bus is in a rest. When bus will start suddenly. When bus will start suddenly, so here what will happen? Bus was already in a rest, and you were already in a rest. Now contact of your bottom body was with contact of a bus. Both were in a rest. But when bus started to travel distance, then that bus came into motion. That bus came into motion, but you still were in the rest. So here, floor of the bus is you so there is a that is where is a reason why you jerks backward. Why you jerk backward? Because when a bed sheet is flicked away suddenly, dust particles fall down because of a external force. Now we have a Newton's law of motion. Newton's law of motion. Here, what is happening? Newton's law of motion. Now we came to the main topic of this lecture. To the main topic of this lecture. Here, let's see. Newton's law of motion. There is object This is object. The block remains at rest. The block remains at rest. It was in rest. Somebody applied force on this object. It came into motion. Uh, so before external force on this object, it was in rest. It uh, it wants it wanted to be in rest, but external force disturbed this object unless and until it is acted upon an external force. This external force is being applied on this object by using this hand. Okay, and external force can be applied on this object by using anything. By using anything. Clear? Okay. Now here there is a ball which is moving. Which is moving. There is a ball which is moving. The ball continues to be in uniform motion. The speed of this ball is in uniform, which means constant. Here, when external force will be applied on this object, then either it will stop or it will increase. The speed of this moving object will be increased by just applying external force. These two things can happen with this moving object when external force will be applied. When external force will be applied. Now next, we have this Newton's first law of motion. Everybody continues in its state of rest or of uniform motion along a straight line unless accompanied by an external balanced force. Again, whatever we saw about the inertia, same here, you will realize everything, anything, which are anything, whatever objects are in a rest will remain in rest, will be in rest. But when external force will be applied on that object which is in a rest, will come into motion when external force will be applied. So what is happening here? That object is changed its self position. After few seconds, that object will cover distance with a time. Ball will be moving, time at the same time will be changing. Time will be changing. What is the definition of a force? Force is defined as the external agent which changes or tend to the change of state of inertia. Push, pull, kick, catch, lift, etc. We know. For the for the discussion of Newton's law, you will realize a word, a phrase, external force. It disturbs a object, a moving object. What disturb? This force, external force, when it is applied on an object, then that object disturb. This is done. I think I have explained what is a force. Now we have momentum. We have what? Momentum. This momentum. Momentum is the quantity of motion. Carefully try to understand. Even I didn't know exact meaning of momentum. I was confused. What is it? Whenever it comes to in front of me, then I starts ignoring this word. Now this time in this slide I think I will be clear. Momentum is the quantity of motion. Are you understanding? Quantity of motion in a body, and it depends on its mass and velocity. Velocity, what is it saying? Mass of the body is less and velocity is more, then what will happen? Then what will happen? Mass is less and velocity is more, then impact will be more, isn't it? If mass is 90 kg and velocity is 3 meter per second, 3 meter per second, then what will happen? You will realize quantity of motion. This with this much speed, your object is moving. Your object is moving. One point is clear that if mass of the object is very less and velocity is more, then that object will move very fast. If mass of the object is more and velocity is less, it means that object will be moving less, will be moving slow. So here you are observing quantity of motion. Momentum of a body is defined as the product of its mass and velocity. This is a formula. This is a formula to calculate momentum. From this formula you can calculate mass. Momentum is directly proportional to mass. Yes, if mass is high, then impact will be more. If a cricket ball and a tennis ball move with same velocity, cricket ball, I am not saying only cricket ball and tennis ball move with the same velocity, momentum of a cricket ball is more. Here we are considering velocity as equal. So momentum, it means mass of a cricket ball will be more. Is more because its mass is larger than that of the tennis ball. What are you observing? If velocity is the same of two objects, but mass of one object is more and mass of another object is less, then mass of a object which is less will be low momentum. So always remember, if a velocity is equal, then momentum it will be directly proportional to mass. I cleared. Momentum is directly proportional to velocity. It can, of course, when mass will be equal, then it will be directly proportional to velocity. For example, there are two objects which masses are same. Velocity is something else. Velocity of one object is something else. Velocity of another object is something else. Now what will happen? If two cricket balls moves with different velocities, then the momentum of the ball with a greater velocity possesses more momentum. Velocity, a object which velocity is more, then that will be more momentum. That will have more momentum. Okay, if a body is at rest, its velocity is zero. Yes, yes, yes. Because a body, if a body is in rest, it means that body is not moving. So of course velocity will be zero. Hence its momentum is also zero. Momentum will be also zero. Okay, momentum will be also zero. Momentum will depend mass and velocity. Velocity is zero, then momentum will be zero. So m is equal to mass multiple velocity. So velocity is zero, then mass is a 12. So 12 multiple 0, momentum will come as a 0. That's it. I am moving. It is a done. Right. Now we have Newton's second law of motion. Newton's second law of motion. The rate of change of momentum. The rate of change of momentum of a body is directly proportional to the applied force. Applied force. F is equal to ma. Mass acceleration. Mass acceleration. In the case of momentum, we were saying momentum is equal to mass multiple velocity. Here, acceleration velocity. Velocity. F is equal to ma. F is equal to ma, and it takes place in the direction in which a force acts. From this law of motion, you will calculate how much forces are being applied on an object. If mass of a body will be more, then you will apply more force. That is how you will calculate. But when it will come to mathematics, how to calculate as a numbers, then you will have to use formula, and formula is what? F is equal to ma. So remember, in simple words, in simple sentence, you can say, if a mass of a object is more, then force will be applied more on that object, then that object will move, that object will accelerate. Now mass of a object is less, then of course we need to apply less force. Somebody will apply less force. It depends on what is the requirement. So here force proportional into change in momentum upon time taken. This formula is a 4, and uh, here a was written in place of b minus u upon t. A was written because a is equal to v minus u upon t. That's why k here it is a k is a constant. K, a value of a k here would be 1. Here would be 1. Now if directly proportional to delta p. P is what? Mv minus mu upon t, time taken. M is a common. M was taken as a common, and here a formula is coming of acceleration. If a force of 1 Newton applied on a body of mass 1 kg produce an acceleration of 1 meter per second on a body, then force is 1 Newton, and this much Newton is applied on this object, which mass is 1 kg, and it produces acceleration of 1 meter per second. Then one will be force, and k constant, k is 1, and 1 kg is what? Mass of object, and 1 is acceleration. Then here k would be 1, k would be 1, k would be 1. This is done. Now next we have applications of Newton's second law of motion. Applications, let's see. A cricket player moves his hand backwards on catching a fast moving cricket ball. That cricket player will move his hand more. He can move his hand more, but according to requirement he will move. He will see that velocity is more, velocity of a coming ball is more, then that cricket player will move more his hand while catching the ball, while catching the ball, that so that his hand cannot hurt. A fast moving cricket ball has a large momentum. It will impact more on his hand. That's why he will take his hand back more. Okay, this was a application of Newton's second law of motion. Now we have examples, applications of Newton's third law of motion. From this, you see what action, reaction. Action is seen on a body, and reaction will be seen on another body. So here, if for every action there is an equal and opposite reaction, a equal action reaction. If action is a 58, then reaction would be 58 as it. From this only you will see nature of a force. What is the nature of a force? If action is taken with some newtons, then with that some newtons will be what reaction. That's it. Laws of conservation of momentum. The law of conservation of momentum states that if no external force is acting on a system, the total linear momentum will remain constant. That's it. Momentum before collision is equal to momentum after collision. It is saying when external force will not be applied, then what will happen? Then that object will remain in state, or that moving object can be moving with the same speed. This is what is the meaning of this slide. Now here in front of you there are three cars. One is here, one is over here, and one is behind this. Suppose a big and a small car move in the same direction with a different velocity. This is one, and this is one, and here is a one. There are three. Let's say this one and this is second. This both are moving with a different velocity. Let the mass of the bigger car be m, and its initial velocity is u. We are considering mass of this object as a m and velocity as a u. Suppose that during the collision, the bigger car exert a force F on this one. This is a calculation numerical for you. I am ignoring it right now. It will be for you. We have another example. Force on a bullet. Here, when this is used, then bullet comes out from this gun with some force. Then this side will come out something with the same force. This is what reaction of this action. Here Something will come will be a reaction of this action, which will come this side, which will come out this side. So this was about the Newton's third law of motion. Next we have rocket propulsion. Same here, this is also about here, this is action and this would be, this is action and this is a reaction, this is action, this is a reaction. Okay, so that's all. We have completed this lecture. We have completed this lecture. So finally it is over. If there is a part 2 of this lecture, then I will bring that lecture in front of you, so that we can understand, we can discuss that lecture part 2. Okay, so that's all right now.